Okay, let's dive into this. Welcome to This Explainer, where we are going to completely transform your approach to the Cambridge Computer Science exams. Whether you're currently studying syllabus codes 0417, 0478, 0983, 0984, 2210, or you're specifically tackling the really rigorous AS and A-level 9618 paper, you are in exactly the right place. Today, we're focusing on mastering a highly specific, notoriously tricky topic, bit masking. Specifically, we're looking at testing and setting a bit. But listen, we aren't just going to sit here and look at the theory. We are going to break down the exact step-by-step strategy required to extract absolute maximum marks from the examiner. Achieving top marks in these specific programming and logical questions, it requires a very targeted, highly focused kind of intellectual effort. Think of it like this. You don't run a marathon here, you execute a perfect, focused lift. Just like a weightlifter. Maximum effort in short, strategic bursts.
Now look at this number on the screen, 15%. That is a staggering metric to reveal right out of the gate, isn't it? But it's true. Bit masking, test and set a bit, and its related logical operations can make up roughly 15% of the total marks in Paper 2. Think about that for a second. This instantly establishes the incredibly high stakes of this masterclass. This isn't just some minor niche subtopic that you can afford to skip or just kind of gloss over during your late-night revision sessions. Missing out on these marks, that can literally be the difference between two entire grade boundaries. If you want that A-star, and I know you do, you absolutely have to dominate this 15%. No exceptions. So to get you to that level of absolute mastery, here is our playbook for today's explainer. First, we'll look at the challenge. Second, bit masking core principles. Third, the method mark strategy. Fourth, deconstruct, solve, and evaluate. And finally, the top 3 examiner warnings. Section 1, the challenge, building explosive power for high marks. Let's get into it. Okay, so high-mark computer science questions are absolutely not about vomiting every single piece of technical trivia you know onto the page. That doesn't work. They require that targeted weightlifter approach I just mentioned. You need precise analysis delivered in short, strategic bursts. Let's look at exactly what happens when candidates lack this proper form under the immense pressure of a real past paper scenario. This slide brilliantly illustrates exactly where things go wrong. Let's look at Alex on the left here. Alex sees the phrase bit masking and just completely panics. He overloads the answer with raw computer science facts. He's defining bits, bytes, logic gates, literally everything except answering the actual question. There is zero analysis of the given scenario. It's just a giant wall of text, and the examiner's red pen is just crossing the whole thing out. Now look at Sam over on the right. Sam actually knows the technical answer, but Sam rushes. Sam completely misses the specific command word requirements, like evaluate or justify, and just provides a simple, unstructured sentence. The result? Both of these candidates lose massive marks. And it's not because they don't know computer science. It's because they completely lack the strategy to effectively communicate their knowledge to the grader. Moving on to Section 2, bit masking core principles, the theoretical foundations. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, to avoid the painful mistakes that Alex and Sam just made, here is the absolute baseline definition you must internalize. Write this down if you have to. Bit masking, specifically testing and setting a bit, isn't just about throwing an AND or an OR gate at a problem randomly. According to Cambridge's conceptual framework, it is about applying systematic analysis and structured reasoning to manipulate specific bits within data. Notice those specific words very carefully: systematic analysis and structured reasoning. The academic benchmarks for this topic strictly require a logical structure. The assessment framework explicitly prioritizes analytical depth over superficial breadth. In plain English, showing exactly why and how you are applying a bitwise mask is far, far more important than just scribbling down the final binary string and hoping for the best. Let's break down exactly how you are graded on this, because this chart changes everything. The assessment objectives actually target 3 distinct cognitive domains for bit masking. Look at the balance here on the donut chart. Knowledge and understanding is roughly 33%, application is 34%, and analysis is 33%. A student like Alex from our earlier slide, he only hits that first 33%. He gives the knowledge, sure, but he fails completely on application and analysis. To get the remaining 67% of the marks, the lion's share of the grade, you must prove you can actually apply the mask to the highly specific scenario provided and thoroughly analyze the outcome.
Section 3, the method mark strategy, rewarding the process. This is where things get really interesting.
Listen up, because this is the absolute secret weapon of top-tier candidates. Examiners actually award marks for your process, not just having a flawless final line of code. They desperately want to see your algorithmic thinking, your decomposition of the problem, and your data structure selection. Even if your final binary output has a minor, silly error, a brilliant method will salvage the vast majority of your marks. Let's look at the procedural framework expected by examiners to prove your practical application and algorithmic thinking. It strictly follows these 4 steps. 1. Design algorithms. You must show a step-by-step decomposition of the bit masking problem. 2. Implement solutions. This means writing out your efficient code implementation or your logic gate application. 3. Test thoroughly. 4. Evaluate performance. When you write out your answer, the examiner is actively scanning your paragraph or your pseudocode for evidence of these 4 exact stages. If you try to jump straight to step 2 without showing step 1, you are just leaving precious, easy marks on the table.
So, how do we make sure we hit those method marks every single time in written explanations? We use the PEEL framework. Point, evidence, explanation, link. You make your points about exactly which bit needs masking. You provide evidence straight from the question scenario. You explain the logical operation, like why an OR gate specifically sets a bit to 1. And finally, you link it all back to the overall goal of the computer system in the prompt. A tight, structured PEEL paragraph is literally all you need here to capture maximum value. Now, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump into Section 4, Deconstruct, Solve, Evaluate, the ultimate problem-solving philosophy. Imagine you're sitting in the exam hall. The clock is ticking, and suddenly you're hit with a ridiculously complex data table or a really dense paragraph about a robotics control system that requires bit masking. This systematic approach we're about to cover is exactly how top students tackle that kind of challenge under intense pressure. You don't just read the prompt and blindly react. You deconstruct it. Look at this quote directly from the syllabus principles. It literally states, "Problem solving in bit masking uses deconstruct, solve, evaluate." Guys, this isn't just a polite suggestion from Cambridge. It is the overarching blueprint for algorithmic thinking. By treating the exam prompts like a giant puzzle to be dismantled, rather than just a terrifying question to be guessed at, you perfectly align your brain with the examiner's grading rubric. Let's walk step by step through this deconstruct, solve, evaluate arc right now. Step 1, identify given information. Do a quick 60-second visual scan of the prompt. Extract the core trend. Highlight the registers. Note those initial binary states. Step 2, break the problem into logical steps. Ask yourself, which specific bit are we testing? Which one are we setting? Step 3, solve systematically. Actually apply your bitwise AND to test, or your bitwise OR to set. Step 4, check for reasonableness. This is huge. Did setting bit 4 accidentally overwrite and alter bit 5? Step 5, make justified recommendations based on the final outcome. If you rigorously follow this exact flow, your answer practically creates itself. Now, for those of you aiming for the absolute maximum method marks, the true A-star territory, you must demonstrate what's called evaluative thinking. Top-scoring candidates do this flawlessly by demonstrating 4 key traits in their answers. They consider multiple solutions. They analyze trade-offs. For example, they might explain exactly why bit masking is far more memory efficient than other data tracking methods. They openly acknowledge limitations. And crucially, they justify all their decisions using clear evidence directly from the exam prompt. Doing this elevates your response from just being technically correct to being undeniably exceptional.
Section 5, Top 3 Examiner Warnings. Avoiding the pitfalls. This is absolutely crucial, so pay close attention.
Look, even with the best framework in the world, candidates still stumble. We've actively scoured the Cambridge Principal Examiner reports for the 9618 paper, and we've identified the exact pitfalls that rob students of their 15% mark share. Let's unveil the direct warnings from the actual people who grade your papers. Here they are, the top 3 fatal mistakes. Warning number 1. Answers on bit masking are often just way too vague. You cannot simply write, use a mask, and expect a point. Examiners demand highly specific technical details. You have to state exactly which logical operator you're using and what the precise hexadecimal or binary mask value is. Warning number 2, students constantly forget to check boundary conditions and edge cases. Think about it. What happens at the most significant bit or the least significant bit? You must explicitly account for these in your logic. And warning number 3, which is hands down the biggest offender of them all, answers are not specific to the context given in the question.
Let's play a quick game of Find the Flaw. Listen to this totally generic answer. An OR mask is used to set the bit to 1. Okay, sure, functionally that is true, but it is completely disconnected from the prompt. It's incredibly vague, it loses marks instantly. Now compare that to a high-scoring context-specific answer right next to it. A bitwise OR operation with the mask 0001000 is applied to the status register to set the header flag bit 3 to 1 while leaving the other sensor states unchanged. Wow. Do you see the difference there? The context-specific answer links every single technical point directly back to the given scenario of the header flag and the status register. Context is literally everything in these exams.
To ensure you don't blank out and forget these complex factors under exam pressure, here is a brilliant secret memory hack directly recommended by examiners. Create a unique acronym. For instance, when dealing with bit masking, you might use the acronym MASK. M for manipulate the specific bit, A for apply the correct logic gate, S for state the exact binary value, and K for keep context in mind. By creating a super simple mental trigger like MASK, you ensure you never, ever leave out those specific, juicy details the examiner is actively hunting for. All right, let's recap the 3 absolute golden rules that guarantee top marks in Cambridge computer science. 1, command word decoding. Always identify if you are being asked to state, describe, evaluate, or justify. Decode the command before you write a single word. 2, Peel framework application. Structure those written answers with point, evidence, explanation, and link. 3, time management matrix. Use the deconstruct, solve, evaluate method swiftly to ensure you don't accidentally blow 20 minutes on a tiny 5-mark question. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with this final, provocative thought today. As you sit down to practice your very next past paper, I want you to stop and ask yourself, is your next answer truly context-specific, or are you just blindly repeating generic textbook facts, hoping for the best? Because honestly, that difference right there, that is the gap between a C and an A star. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.